A very good morning and a warm welcome to ladies and gentlemen. Uh, Welcome to our event today, where we'll be exploring the impact of AI and the future of work and on building the digital economy through urban rejuvenation. So I'm Zai, Research Manager here at the Asia School of Business and your host for today. So we're very honored to have Professor Silvio Meira, the chairman and co-founder of Porto Digital, and our first distinguished fellow here at the Center of Technology, Strategy and Sustainability here in the Asia School of Business, to share some of his thoughts on some of these issues. So to give an agenda for today, firstly we'll hear from Professor Silvio on AI and the future of work, and that will be followed by a brief break. After that, we will have a moderated forum on building the digital economy through urban rejuvenation, together with some of our distinguished panelists. Now, to begin our event today, I would like to invite Professor Renato Lima-de-Oliveira, Faculty Director here at the Center of Technology, Strategy and Sustainability, and the Assistant Professor of Business and Society here at the Asia School of Business, to give a few words of introduction and to introduce Professor Silvio.
Thank you, Zai. I forgot my speech. Fatin, do you know where's my speech? No? You know what? Can you change? Yes. Let me do something. Please write a 10-minute speech introducing Professor Silvio Meira from Porto Digital to an audience in Malaysia at the Asia School of Business. I hope this can save me. Let's see. It's an honor and privilege to stand before you as we gather here to introduce a distinguished individual, true visionary pioneer in the field of technology and innovation, Professor Silvio Meira, who hails from the vibrant ecosystem of Porto Digital. Let's have more of a look. Remarkable work of Silvio Meira, reflect on the power of ideas, force of innovation, transformative impact. He's one of those brilliant minds who has significantly contributed to the world of technology, innovation, and entrepreneurship. Porto Digital, situated in the heart of Brazil, all good. That his influence extends far beyond the walls of academia, dynamic force, academia and business spheres, multifaceted career showcase the fusion of academic rigor with real-world impact. Man, this is exactly what we do here at ASB. I think you're in the right place. That his commitment to fostering a culture of innovation and entrepreneurship, his role in establishing Porto Digital as a hub, his work extends well beyond Brazil, has been a tireless advocate for the global exchange of knowledge and ideas. He believes in the power of connectivity, leveraging technology, and so on. Man, this is amazing. I don't need ChatGPT to write a speech to introduce Silvio, because I know Silvio for 20 years, or even more, but it's amazing what you get out of it. So let me give the flavor that ChatGPT won't be able to give you the flavor of who Silvio is. Silvio is an inspiration to a lot of people in Brazil and abroad. When I was an undergraduate student in 2000, when I started my bachelor's degree at the same university that he was teaching, Universidade Federal de Pernambuco, where he's an emeritus professor, people look at the Center of Informatics as a model, as something to aspire, as part of the university that was really working, that had the best computers, the best buildings, the highest connection with real-world impact. So we look at that as something that is the future that we wanted. And he was able, with a team of leaders, and I will have to stress that a deep, profound change is not only done by single individuals, but rather by a coalition of people working together on a mission, on an objective that creates a shared trust and shared hope. And he was able to be this leading figure that said, hey, culture of Pernambuco, economy of Pernambuco, do not be trapped in the past, into the legacy industries. It's time to focus on a different type of industry, and we need to have the hardware for that. We had the human resource, we had the software for that, the ability to convert knowledge into code. But we didn't have the rest of the economic structure that would be able to support retaining those talent to stay in Pernambuco, stay in Recife, stay in Brazil. So together with a group of visionaries in Secretary of Science Technology, other academics, business people, he was able to, within a coalition, put together an initiative called Porto Digital that then renewed, really changed the hardware of one of the most historic areas of the city of Recife. By the way, Recife is the size of Kuala Lumpur. It used to be known as having a certain type of economic activity, and now, perhaps globally, it's most associated with the digital tech hub. Being also health services, another very important activity in real estate construction. But it's the technology that is really a mark, it's really something that we are proud of. In the whole story of his career from academia to interacting with industries, developing solutions, training a lot of high-skilled workers through MSCs and through PhD theses, connecting the world in Latin America and the rest of the world. And today we are connecting to Asia, and no better place than doing that in Malaysia. And you can repeat with me, which is truly Asian. So bringing him to share that experience, I think it's something that speaks deeply to what we do at Asia School of Business. And thank you so much, everyone, for joining us today. And at CTSS, our Center of Technology, Strategy, and Sustainability. So let me remind here, what is the mission of ASB? It's to become a premier school of management in Asia, recognized for its ability to develop transformative and principled leaders who will contribute to a better future and the advancement of the emerging world. So that particular piece of advancement of the emerging world is something that speaks to the core of what we do here. We don't want to be a copy of a great business school that you have in the United States, that you have in the UK, you might even have in Singapore, and it's a joking, that you have in other places of the world. We want to be unique. We want to be unique in the way that we teach, in the way that we attract talent, in the way that we want to develop and participate in the further development of Malaysia's ecosystem. We do that through a network of also leaders, business leaders, policymaker leaders, that they see that Malaysia is the right place to be in terms of innovation, entrepreneurship. We just need to put the piece together. And that is something that we are also going to address in the panel that will come after Silvio's talk. So, to be recognized as this premier business school to develop principal leaders and advance the emerging world, we need to be connected with the experience of the emerging world. Managing in a country like Brazil or Chile or Bolivia or Thailand or Cambodia or Laos or Nigeria or Somaliland and so on, you are going to face a set of challenges that are very, very different than what you have starting a business, say, in Texas or in Boston or in Ohio. The challenges are going to be different. The availability of human capital is going to be different. Funding is going to be different. Regulations are going to be different. The impact of political changes are going to be different. So we have a lot to learn from other emerging economies. What are the challenges that they face? How they try to overcome such challenges? How can we think about the parameters that you have to adapt and see if it works in a different ecosystem? And sometimes you do that, we at Asia School of Business, we do that by having students working directly with companies. Right now, I'm advising 2 AL projects. One working with a company in Thailand, a multinational company in Thailand, introducing different products, portfolio of products to ASEAN market, and also another company doing R&D tech work in Singapore. All of that expose our students to a reality that you are not going to get going to a top business school in most places in the US, Europe, and so on. You might read cases, you might understand what some business leader did at a certain instance to face a particular challenge. It doesn't give you the real world experience, and particularly doesn't give you the experience of managing in an emerging market. In that connects, so that's the teaching aspect, the replication of knowledge and discovery of knowledge. But we also do a lot of research. And here at Asia School of Business, with our fantastic colleagues, we have different research centers. I have the honor of leading one called CTSS, Center of Technology, Strategy, and Sustainability. And the aim of CTSS is to be a leading center of excellence in research on business strategies and technology in emerging markets in their social-political environment. So considering ASB's mission in CTSS mission, I don't see anyone that it's a better fit to be with you all today, and also to be our inaugural distinguished fellow than Silvio Meira. Silvio has a distinguished career. He's also very charismatic. So listening to Silvio is always a pleasure of the ear and of the brains. Like you learn and you also like what you're learning. So in a few moments, you will have that opportunity that I had also the privilege of experience for over 20 years since I was an undergraduate student. Let me conclude those words by thanking our team at ASB. We wouldn't be able to reach what we have reached without the indefatigable work of our team, of the many different people that compose our team. I think Silvio is going to speak about the obsolescence of the median professional, how AI challenges a lot of the work people do, especially if you are not excellent. I'm very happy to see that our team at ASB is not going to be threatened by AI, because they are so smart and great and good, operationally amazing, strategically ahead, that they are the ones that are going to use AI to increase their productivity. So let me start by thanking Zai, Natasha, Fatin, Shri, Aimi, Ganesha, Emir, Peter, Daniel, Rachel, Zahara, Zara, Kayan, Jiawen, Charon, Gillian from CG and team, Lily and team, Suzanne and team, marketing and team, AV team, faculty, our C-suite. It takes a lot of work, a lot of people, good people, to put together a whole operation that we have here at ASB. And the operation is run by Christina, so thank you so much, our COO as well. I think that the sense of proud of building something, building institution that we have here at ASB, a new school for the world, in Malaysia, but for the world, I think you will also hear from Silvio when talking about the things that he has done that took decades, but it has been transformative where it's based, Porto Digital and going abroad, now also in Malaysia. So with that, Silvio, the floor is yours. Thank you.
Good morning, everybody. It's a great pleasure to be here I'd like to start by thanking Renato and the whole team at ASB for inviting me here, having me here. I had a wonderful reception, and it's really wonderful to be in Malaysia with you. What I'm going to do right now is to share my slides, if I may, and make it sort of very clear that we have two parts of this morning. First, I'm going to talk about AI, but not just about AI. I'm going to talk about AI within a context of many more things that are happening and have been happening for ages, maybe at least a quarter of a century, and discuss the problems that we have and the opportunities we have with AI right now and in the next maybe 10 to 25 years. Then we're going to have a panel about urban renewal through local systems of innovation. But let's start with this AI thing, which is at hand right here, right now. This is my blog. So if you go there, there is 1,100 articles on information and communication technologies and their impacts on society, people, families, economy, firms, whatever. It's in Portuguese, but then that doesn't matter anymore. You can just drop it in ChatGPT, it will translate it for you. This is my Twitter. I kind of publish something there every other day. I'm one of the founders, amongst other things, and the chief scientist at the digital strategy company. I'm an extraordinary professor at the Cesar School, a school in Recife that looks quite a lot like ASB, but it's concentrated in design and computer science. And as Renato said, I'm the emeritus professor of software engineering, which is what I did for most of my academic life at the Center for Informatics at the University of Pernambuco, the Federal University of Pernambuco. And of course, right here, right now, I'm a distinguished research fellow at the CTSS at ASB, which makes me very proud, thank you. But then, apart from being in Malaysia and in Kuala Lumpur and in this beautiful auditorium, where are we right now from the point of view of information? We can write one history of information, not all histories of information, in sort of a 5 big steps. Information, as we know it in the world, starts with DNA. It appears in planet Earth around 4 billion years ago. That's years ago. Then, if you leave information in the form of DNA running, in the world for a very long time, evolving and changing and, trying to overcome the challenges of the environment, much later, kind of 4 billion years later, or something around 14 million years ago, you have brains. Once you have brains, and the brains get complex enough, several million years later, they will do something magic. They will start trying to extend your limbs, your body, with things like knives, axes, levers, things that make you stronger or make you reach longer. It takes quite a lot more time, for example, for you to develop glasses like these, which are tools as well. But they are much more difficult because the physics involved is much more difficult to process as tools. It needs some pre-tooling for you to make different tools that process optics, process light, like glasses do. Okay, so if you keep running for a few more million years, then you have text. Text, the first written language that uses an alphabet close to what we have these days is Linear B from the Greek islands, and it came around about 3,500 years ago. And if you keep doing stuff to process text, to understand text, and text itself does something magic, which means that you can delocate brains, text itself. You can send a book somewhere. By sending a book somewhere, people in that somewhere are going to read and understand part of your thoughts. So you abstract with books, especially after the industrial revolution of books, starting around the 1400s, you can send people's brains to other places. Right. So, not much later, considering the time scales involved here, you start having code. Code as text that some kind of machine can use to repeat some action that humans used to do. It started with sequencers in the Arab world, more or less around the year 800, for weaving carpets and fabrics of all sorts. And with computers, code started in around 1949. I like to use that date because of some specific theory that happened there. It's useless for us to talk about it here. But the fact is that 70 years ago, somehow, you start having computers as we know them today to execute code, all right? Okay, as soon as you start to write code as a civilization, you start using code to do things. So from basically 1949 to this date, we started to use code to process code. You know, code running in a computer to process code written for a computer to accelerate your process of developing code. You know, turning code that looks like human written text for humans to translate that text to some other kind of text that the computers understand and can execute. After that, you start processing text. Text in the form of numbers, you know, like in Excel, or text in the form of natural languages. So these are the first two things you start doing with code. Process code proper and processing text. Then you start writing tools. You start to automate work, either with physical bots, physical robots, or you start automating, for example, text review, like with orthographic correctors and text correctors of some sort. Then you, after some time, you start playing with the idea of how do we think? Can we make computers think in the same way we think? And that happened very early in the history of computing. Because if you remember, I said that we had something that looked like code in computers in 1949. And we started thinking about how to write code to make computers think the next year, the very next year, in 1950. Okay, so the next bit of it is that you're gonna use, and we are already using, code to analyze, to edit, and to write DNA, which means writing life. DNA is just code, nothing less, nothing more, but just as code. Code as we know it for computers is strings of bits that are processed by an infrastructure of silicon. And code as bits for life, like DNA, is a string of bits that are processed by an infrastructure of carbon. So code is something that, one, implements algorithms, methods of doing things. Algorithms are simulations of the world. You kind of did something you proper, and then I write code to simulate myself doing that thing. So code creates world simulations. And of course, algorithms in the form of code can intervene in the world. That's what Renato actually was saying there. He could put, for example, ChatGPT to read the answer to his question, and then we'd have ChatGPT actually introducing me from a question that Renato had asked. This business of algorithms is sometimes magic for people to understand, but we can see it very easily here. This is an algorithm. That's the multiplication of natural numbers. It comes to people at primary school. So 43 times 25 is 1075. And it's done like that, and you know that by heart ever since you were, say, 8 years old or something like that, right? No problem. This is an algorithm. This is an algorithm. And it's been here since early Babylon. It has been around us for basically 5 millennia. This is when the Babylonians started writing tables that led them to deal with multiplication and division, and pretty much 1,000 years later, they decided tables were too big and too complicated to deal with if you had to multiply large numbers, and then they started writing algorithms to do that. So algorithms are with us for millennia. But then something happened. The arrival of the possibility of having algorithms not written by humans for humans to execute, like that multiplication of naturals, but algorithms written for computers to run. That has 3 dimensions. First, a dimension of computing proper. That started in the 30s with theories by Kurt Gödel and Alan Turing and Alonzo Church. Those guys, they actually designed the foundations of what we know these days as computing, with one universal machine that can do everything that can be done by computers. That's the universal Turing machine designed by Alan Turing, with one minimal language that can do whatever any other language can do. That's the lambda calculus, which was proposed by Alonzo Church. And a theory of how those things get together by Kurt Gödel. What can we do and what we can't do with formal systems. So computing as a theory came in the 30s and became practical in the late 40s, as I have said already. Then computing was followed by communication. That's a set of theories in the 40s that taught us how to send information from point A to point B in a sort of resilient way, understanding the principles of what we were doing. Also in the 40s, the late 40s as well, and in the same place, communication and control theory are both from the United States, exactly from the MIT. We started thinking about how to control things at a distance using information that would come from things to be processed, to be turned into commands to affect those things. That's the cybernetics theory of Norbert Wiener. And this led us, in the last quarter of a century, to do something magical. We wrote the entire of society in code. That's not news, because we were doing that already for millennia, as I have told you. But we put that code online. If you have a look at this graph, the first website went live on the 6th of August 1991. And then we connected the world. We connected the world to the point that in Brazil, everybody 10 years old or older, nearly everybody, 81% of all Brazilians that are 10 years old or older, they have a smartphone and a data subscription of some sort. 81%. That's 165 million Brazilians out of a population of 203 million. That means code is everywhere. Code is mediating our view of the world. Code helps us to do things. Sometimes code enforces us to do things. Everywhere, at all times, anytime, anywhere. Basically, your service providers actually know where you live, whether you have allowed them to know that or not, for one simple reason. They know because they have to send information to you and get information back from you. They know where your cell phone is. That's a basic necessity of the information service provider to send you bits and to get bits from you. And your cell phone stays in a given place, let's say from more or less 8 p.m. to 8 a.m. That place is your home. They all know that. That's not a problem, necessarily. But it's a disruption. It's a disruption to start with the disruption of space. forever since before the arrival of code online, if you wanted to start a business, it would be in the physical dimension of the universe around us. For example, in this street, this is the Via dell'Abbondanza, the street of abundance in Pompeii. It was, you know, buried by the eruption of the Vesuvius volcano in 79 of our time. And if you go there, you can see that sort of business. This is a self-service restaurant with the signs you'd find in one today. Keep your dogs on the leash. We sell coq au vin, you know, fried duck, Malaysia style, with herbs. And a person would go through the pots and pay somewhere and eat. So in the beginning, everything was physical for obvious reasons, right? But then, around 1995, all over the world, you create or you start providing a new dimension of reality. That dimension is not only digital, it's digital connected, digital networked. Digital networked operates something magical. It can virtualize, it can delocate, it can abstract the physical reality of shops. For example, if you have a look at this Amazon web page here is from early 1994 and says basically what any other online shop would say these days, including we have eyes and editors to actually suggest you stuff that you never thought you needed, but you're going to need from now on. That's Amazon 1994. But it wasn't only that. We added a social dimension, a dimension where, given that you would be abstracting physical space, you had this other dimension to connect people and the physical space abstracted, which meant that this person would go to this shop, would not like it, would go to that one, would like it very much, and then suggest it to those people, creating network effects, things that happen when some people using things make those things much more valuable for everybody, including those that do not use it. This created a new space. It's not something that digital came as technology or platforms or anything, but creates a new space of three dimensions: physical dimension, digital dimension, and social dimension, creating a phygital space. This here should be indeed physical dimension and not phygital, because phygital is the whole space. And in that space, what happens is flows. Manuel Castells, in 1996, famously said that in the future, when you'd have the internet connecting nearly about everybody, everything would be sequences of purposeful, repetitive, and programmable interactions and exchanges carried out by social actors, which are people, organizations, things in the Internet of Things, situated in physically disjoint locations, anywhere in the phygital space. He didn't propose the phygital space, that's something we did, over the economic, political, and symbolic structures or platforms, he didn't say that as well, of society. Everything would be flows. And that's what we have today. And platforms are so important, so relevant, that maybe we should define them. Platforms are systems that support communities and applications and can be the platforms, those systems, customized or programmed by outside developers, people that didn't were part or are part of the original developers of the thing. They didn't contemplate the apps we thought about when, for example, the Android developers and iOS developers actually created a whole ecosystem of applications that solve problems that neither Google nor Apple actually thought of to start with. No community support, it's not a platform. Not programmable, not a platform either. But platforms, when they do exist, they are combinations of infrastructures and services with a certain kind of governance to say how we can use their interfaces to write applications that individuals, collectives, and organizations both write applications and use applications to create connections, relationships, and put communities together where interactions happen, meanings are transformed into culture that make transactions possible. Cultures of needing something, of using something, of understanding the world. So in a certain sense, platforms create ecosystems of communities that are the world's current markets. Where are we now? This is the world around us for nearly everything you and I do. For example, I've discovered through Renato that I wouldn't be able to survive in Kuala Lumpur without Grab, right? It does that. It's markets for everything. It's a platform that created an ecosystem of communities, for example, of drivers that have cars that brought me here today, and myself that came from all the way from Brazil to ask for a car this morning to bring me here. So, this phygital space actually had this plane here, digital social plane, created with and based upon informatics. This is the combination of computing, communication, and control. Physical, digital, social, putting together a phygital space that was created on top of informatics, or the combination of computer science, computer engineering, and engineering of control engineering. This is a space of platform ecosystems, and that's been causing disruption all over the world in a phenomenal speed. One of the disruptions is the inversion of business models. And here we compare what was happening before to what's happening now. When we think about innovation, most innovation that happens in the world is based upon incremental steps. You are doing something and you do something else, but not too much different from what you've been doing before. Once in a while, you have something that disrupts the context around you and eventually destroys entire markets. This is transformation. The step is too high for most companies to actually go from here to here. One of the things that's happening now, and most companies are not understanding, is that we are transitioning from the ways of the Industrial Revolution to do things in relation, for example, to products of business models that depend upon the Industrial Revolution, where and when you did things like putting together a product and then going to the market and looking for clients. That step of actually transforming the world in platform ecosystems of communities that are markets means basically that you build ecosystems of communities, and then within a given community, you are going to search for products for clients. You already have the clients. Grab. I'm there. It grabbed me. Right? That's why the name's Grab. It's not because you grab something from it. It grabs you and makes you part of their community ecosystem. And then you go to another community and you look for services for clients. And generally, at all times, because it has of our data, Grab is doing something nearly magical. It's processing vast amounts of data every day to try to discover which problems do we have and we don't even know about. And it's doing that for every click we are trying to get something from. That also does something magical, which is second kind of transformation. It reorganizes businesses that came from the Industrial Revolution. If you look at the Industrial Revolution proper, we are talking about siloed businesses that are put together in pyramids of levels of command and control. The principles of that sort of context, or business, or markets, or entire economies, are the principles of command and control in legacy industrial era organizations. Decision is top-down, hierarchy is levels and silos. You decompose work, obviously to conquer complexity. You specialize everybody to put together assembly lines of anything. You optimize, it's missing a P here. You optimize everything, looking for a global optimum. You resolve conflicts by atomizing the organizations. You centralize planning and do it once and for all, once per year, which is, for all, giving the speed of change of the times around us. You train and evaluation people to repeat things forever in a just do it mode, and you micromanage everything. It's a universe of managers. When you actually transform the world from pyramids to networks, which are the current markets around us, the principles are different, wholly different. Principles of learning in performance in businesses of the knowledge era. This is where AI starts to play a role that's completely new. Here you have to articulate purpose. Instead of defining strategy, you orchestrate it through collaboration. You decentralize communication, you distribute decisions. You have to go for the 3 R's of robustness, resilience, and responsiveness to execute, to deliver. But you also have to do it in a flexible, adaptable, and innovative way to change the business and maybe change the market of the business or change with the market, because it may be the case that your market is being transformed into something else that's unrecognizable for you. That means networking the organizations. My particular point of view is that with the transformation of vertical into networked markets, vertical markets being transformed into networked markets, the vertical organizations are not going to survive. You have to transform your organization in a network. That means that much more people everywhere in the organization will have to decide something for obvious reasons. You don't have the time for the problem to move all the way up to where in the industrial era organizations people would decide something. You have to decide where the problem is. Why is that so? Well, we have data for that. The Chaos Report, it's a report that's published every 2 or 3 years. The last one published in 2021 analyzed close to 11,000 projects. What did they discover there? They discovered that when the time to decide something where the problem is below 1 hour, the rate of success of projects is around 68%. You still lose 32% of everything you do. Lose here means that you didn't solve the problem given the time frame, the investment, the quality, and the acceptance of what we were doing. They analyzed project using all sorts of technologies in all sorts of markets, from industry to health to education to government. When the latency, the time to decide something where the problem is, goes above 5 hours, you lose 82% of all projects. And of course, this is a business school. I guess you can agree with me that it's impossible to run a business that fails 82% of the time. Right? So, what do we have to do? We have to move to a universe of learning and performance, which everywhere, in all sorts of organizations, is done by people. It's done by people. And it's done by people and their intelligence. When we look at that, intelligence is a combination of 3 factors that we could call dimensions of intelligence. The first dimension of intelligence is information processing. You were listening to me, you're seeing my slides, you're getting your context, you're processing that, and you may react with your head saying, he's wrong. Or, I agree with him, more or less. Or, don't know what he's talking about. Doesn't make sense to me, right? This is your information processing capability. We have another capability, we humans at least, which is autonomy. You all decided to come here today for whatever reason. You didn't have anything to do, you thought it was going to be a talk, or a good talk maybe. There's a Brazilian speaking about something that we don't know, and so on and so forth. And there is a third dimension of intelligence, which is our capability of getting together with other people to solve problems that we can't or we think we can't solve alone. Socialization. These three dimensions of intelligence are embedded in that picture we were talking a few minutes ago. You know, phygital space here. So right there, this wall of it, the digital social plane, as we have seen already, was created using informatics, computing, communication, and control. All of this here is actually equivalent to only the informational capability of human beings. You know, if you put software together and connect it to other software and so on and so forth, it will have autonomy in some sort of way, but nowhere near. We are talking many, many orders of magnitude below the autonomy in socialization capability of human beings. All right? There's a missing part of the picture here, as you might have guessed. Learning, as we are doing here at the school, in this moment, I hope, does something. It transforms individual intelligence into collective expertise. So, we are not learning something as per each one of us. We are, as a group, creating an idea of what's happening in the world as a function of I'm saying, and we are learning together, and we'll keep learning in the debate, in the questions to this talk. In the past, there were two dimensions of intelligence that we could perceive kind of normally. One of them was the intelligence of each one of us, and the other obvious intelligence was the intelligence of most of us together, groups trying to solve problems, and that dimension was created by our socialization capability, of course, right? So this was the plane of intelligence before AI, and then AI appears. My point here is that AI is not a technology, it's not a platform. AI is a new dimension of intelligence, and we have to think about it and of it as such. AI is a dimension of intelligence with which individuals and groups can work together to augment our individual and collective intelligence. And it may be very difficult to do it, because the picture is this one now. We used informatics to create the digital social plane, to impose it upon the physical reality. This is only, as I have said already, the informational part, the data processing, the information signal processing part of human intelligence. And this informational, or the whole of our intelligence as humans, is the individual dimension of the space of intelligence in the world at large right now. This is the picture so far. I'm going to improve it somehow. Why did I get here? Because if I were to give a talk on artificial intelligence, we'd miss the picture. The big picture is we have a new dimension of intelligence, and it is online. What made the difference here was not that we had digital. Digital was with us from the 40s. The difference from the 70s onwards was that digital was connected, and everybody could see, everybody could listen to it, everybody could use it to write code, to do things, to do marvelous things. We've changed the entire world in the last 25 years. And I think this thing here as a dimension is going to change everything again. To this point, the lady is asking, what will be the impact of ChatGPT on our business? And then the man here says, well, there's a lot we don't know for sure. Parts of it is made up, and it will take, or is it going to take away our jobs? What are the security risks? Is it going to damage our reputation? And then she says, okay, but do we know anything for sure? He says, only that we want to adopt it everywhere as fast as we can. Data, again, 68% of all the CIOs that were heard by a global research institute now in September said that they will try to adopt ChatGPT and technologies like it in all parts of their businesses over the next 18 months. 18 months. To adopt something, you don't know what it is. You don't know how it works, and you don't know what harm it can do, but you're going to do it. It's just like the internet, right? The internet said, well, there is the internet here. We have to have it. Looks like a GPT. GPT in another sense of the word. GPT is a general purpose technology. It's going to change everything, and if you don't try to use it, it's the same thing as not trying to use electric power in the 1910s, right? So, no, I don't like electric power. I prefer, burning whale oil at night for dinner. So we're going to have light, and everyone is going to smell like a fish. In history, if we look at history, what happened? Let's see history in the long term again. We are here at moment zero, just because we are here. It's not special, right? So if you have a line, we can say basically of the last 100,000 years that we got language, started to speak like we speak these days 100,000 years ago. Then we have writing. That's, 3,500 years ago. And we have the press in 1455 or something, right? That's more or less when we started the information revolution. Then we have code, some 70 years ago. We had the internet, more or less 25 years ago. We had the blockchain, more or less 20 years ago, or in other terms, 15 years ago. And right now, at moment zero, we have AI online. It's not AI. AI is old. We have AI online. So what happens from now on? What happens from now on is that because 7 years ago, we started developing the capabilities to write systems that in thesis can write anything that we can write. We started to write code that, in the long run, can write anything that we can write. And write here means paint, compose, draw, write proper, do anything that we can do. We can at least imagine that code is going to have some sort of capability like that. It might be the case that we're starting the era as well of Homo artificialis. People that are powered by artificial intelligence, right? Okay. But AI comes from something much simpler. In October 1950, exactly 73 years ago, Alan Turing, one of the founders of computer science, wrote a paper called Computing Machinery and Intelligence, centered in that question I told you before. Can machines think? It took us 70 years, basically, to get through large language models, like the one Renato was using here, ChatGPT. What is ChatGPT? It's embedded in that phrase. A large language model, or an LLM, is a type of algorithm, like that multiplication algorithm. Of course, it's longer, it's much more complex, but it's an algorithm like any other that makes use of deep learning techniques. These are special techniques that you use one algorithm to build another algorithm out of it, using to do this out of it huge data sets that we have because of the internet. OpenAI, the makers and providers of ChatGPT, actually captured a big portion of the open internet to create as if it were an algorithm that, given a question, it answers that using whatever it learned from what's written on the internet up to the time it was, quote, created. The technical word is trained. And this algorithm can, quote, and very quotely, understand. It doesn't understand as we understand. It's not a model that has a foundation. It can process text, and you can think it's understanding something, but it's not. It's pattern matching. It's creating patterns, matching the patterns out to things it has seen already, and looks like a statistical model of comparing things with other things and saying, this thing I'm seeing now has a 95% probability of being this question's answer, like it did for Renato. It's worth noticing that in Renato did a previous question here to try the same ChatGPT with the same login, and the thing said in the previous answer to the same question that I did an MSc in Grenoble in France and did my PhD in the United States, right? And I didn't. I did my MSc in Recife, in the institute that I helped to reboot after my PhD, and I did my PhD in Kent at Canterbury in the United Kingdom. Okay, so it doesn't understand, really. Looks like understanding, but it summarizes much better than most humans. It generates answers that are equal or better than the median human doing the same thing, and predicts more or less a number of things without, failing most of the times. Okay, but that's old, because these kinds of systems, without the huge data sets and the deep learning techniques, started around 1967. It was the first natural language processing system that you could converse with, right? The theory for ChatGPT was published in 2017. GPT was made public for the science community in 2018, and ChatGPT, of course, in November last year. This November last year is that AI online point in my timeline from humans to humans powered by AI. And this has huge impact in the world around us. For example, if you look at the median of what the big consulting houses think it's going to be the impact of LLM plus LLM, large language models, plus artificial intelligence, plus platform, ecosystems, automations of all sorts. And that's why, I was talking about platforms here, because it's the combination of everything that's been happening since the early 90s. The expected impact means subtracting and adding value to markets per year. In 2030 and onwards, it's going to be something like $15 trillion per year. That's 8 times the economy of Brazil, which is one of the biggest in the world, and it's around the size of the economies of China, United States, and Europe. It's not the same size, but it's like putting together a whole of the economy of Europe per year in terms of impact in global economies. And where is that going to happen? This line here is when you combine AI, information technology of all sorts, including platforms, with large language models. We are saying that applying expertise will have an impact in close to 60% of all of what it does. You know something, you're going to use it to solve a problem. Around 60% of all of what you do is going to be impacted by AI plus platforms plus LLM. That's going to be 49% in managing stuff. It's going to be around 45% in interfacing with stakeholders. And notice that things like processing data is around 90%. AI is quite good at processing data. And it's getting good at doing physical stuff as well, even without large language models, because we still don't know how to use them to do things like performing unpredictable physical work. But it's not going to stay there. It's going to be much more than that. So how to use this? I mean, you're here now, you're going to go home to your businesses, to your government offices, and you're going to do something with it. Okay? We can use it to augment and assist humans. Like, for example, in healthcare, you can use AI-powered diagnostic systems to analyze medical images of all sorts. This has been in use already for more than a decade to detect abnormalities and assist doctors in making accurate diagnosis. I'm not going to read the rest, otherwise we're going to spend too much time here. In education, you can use AI-based tutoring to provide personalized learning experiences. You can use natural language processing models to automate the grading process. We have an AI at my company in Brazil that does that, and does that with a 2% margin of error when you compare it to a board of humans doing the same thing. You can have intelligence chatbots assisting students in answering questions. There is a study, recent study in the US, that students prefer chatbots than professors to do that. They are much more empathic, right, than professors. That's really interesting. In finance, you can do a bunch of things, of course. You can have AI algorithms to analyze financial data and market trends to provide personalized investment advice. That's already the case in most banks you deal with. But then there's the other side of this. Instead of augment and assist, you can reduce and substitute. You can reduce the agency of humans in what they have to do to solve a problem, and you can substitute humans altogether. Kind of AI can analyze medical images to accurately detect and diagnose conditions. This can reduce the need for radiologists' interpretation and diagnosis. You could have AI-based tutoring systems to provide personalized learning experiences, partially replacing human tutors. And of course, you can autonomously execute high-frequency trades, based upon AI. You don't even need AI for that because you already can do that using statistics. You can do a lot of things that don't need AI to do it anyhow. Well, of course, if you got the texts right, you smell the fish there, like this kind of fish. This is the first thing about analyzing medical images. I've changed it a bit here. It's not analyze medical images to detect and assist, but accurately detect to reduce the need for radiologists. If you just tune it in a bit better, instead of helping humans doing the jobs, you can reduce the need for humans and substitute humans altogether. If you look at the same thing in education, natural language processes can automate the grading processes. We can do things like provide interactive lessons, pronunciation, feedback, and language practice exercise, and can replace human language instructors in providing whatever. You go from something pretty basic, grading, that's just basic NLP, to doing everything without humans. From augment and assist immediately to reduce and substitute. And this is going to be choice. Society is going to choose whether you are going to augment and assist humans, or we are going to reduce their use, reduce the use of humans as central processing units, or completely substitute them. For that, we have to think strategically. Again, I don't have the text in English, but then, of course, there is ChatGPT, and you can go there and say, this text is intelligences, individual, social, and artificial, same thing in Portuguese than in English, a new strategic space to create, to collaborate, and act. It's a 90-something pages text we wrote at TDS recently, saying, but you can get it from this QR code here, of course, but saying basically that your choices will depend on recognizing the three intelligences: individual, social, and artificial. Respect individual intelligence as a principal collaborator. We don't want to reduce and substitute ourselves. We want to augment and assist. We want to promote social intelligence. We together. We should, at least, use artificial intelligence responsibly. We would have a better world if we promoted an active interaction between the three intelligences and had an innovative attitude towards the three intelligences. They are already there. We are changing behavior already. Innovation is changing of behavior of agents in the markets. We have to change behavior. We can't negate the fact that AI is with us. And of course, we have to promote digital ethics. And in business, that actually means that the impacts of redefining and evolving the business architecture, how we create value, reorganizing the entire business, organizational transformation, new and innovative business models that are going to be possible because of the three intelligence as a space, and transforming business intelligence shouldn't be hampered by what we could call artificialization. When we had this digital space at our disposal, this phygital space at our disposal, what we actually did in most businesses was to use digital as tools, not as a new foundation to rewrite the entire business and its processes on top of it. Of course, who did it right understood that it was the creation of a new plane that had some foundation based on computing, communication, and control. And now we have to understand that that is just part of our own intelligence, that if we have it together with the other two intelligences in this space, what this thing is going to do is actually to create a positive feedback loop, affecting back the phygital space. And this is going to interact very quickly indeed over the next 5, 10, 15, 25 years. And it's going to cause what no one less than Joseph Schumpeter called creative destruction, which he defined basically like we could define today, not changing a single letter. This is to create or to provoke a creative destruction of flows, which means new combinations of everything arriving that themselves create new methods of production, new products, new markets, new suppliers and value chains, and that will demand new forms of organizations altogether. The postscriptum for this is that I'm writing a paper here about this whole stuff. So sometime in the near future, I hope it will be published in CTSS's website. And it's got the wonderful, marvelous name of the multidimensional impact of automating cognitive tasks through large language models on the future of work and employment. As you can see, you know, that looks like a paper. Scientists write that sort of stuff. And of course, I already said I'm part of the Asia School of Business. It's more or less a long paper. And when you look here in the bottom, there is an appendix. It's called The Imminent Obsolescence of the Median Creative Professional. What's that all about? That's about this here. Maybe we can read it together. I'm finishing. This is my last slide, really. This appendix, crafted to provoke a mix of academic eyebrow-raising and contemplative chin-stroking, kicks off with the daring working hypothesis that conversational large language models are on the cusp of making the median creative worker and everyone beneath that threshold obsolete. A simple corollary of the hypothesis is that PhD students are creative workers. So all the median PhD students and below them are obsolete as well. Why is that? Why is that? You know, the core of the threat to PhD students that we are trying to automate, ever since Turing in 1950, thinking labor, the work that involves intensive information processing, reasoning, and ideation. So when you look at what PhD students do, they do things like text generation, summarization, and asking complex questions. And that's what we can start doing with large language models right here, right now. So what am I saying with that, apart from provoking the ire of the scientific and academic community, which I'm quite happy of, by the way. What I'm saying here is that if the job of PhD students is at risk, at least for those below a certain median, all of our jobs are at risk. And we have to do something about it. And I think it's responsibly designing policies and strategies and regulations for the use of AI to augment and assist humans instead of reducing and substituting them in all of what they do. Is that the end of it? Nearly so. The conclusion of that paper is already written. I think AI can lead to increased productivity, cost reduction, and economic growth, but also poses a huge risk of job displacement and further income inequality. The deployment of AI should focus on augmentation rather than substitution. There is already a need for proactive policy and adaptive strategies to address the rapid progress of AI, which is more or less in a big bang sort of moment right now. A dual investment approach in both AI and human capital might maximize benefits and mitigate risks, of course. I am here, cautiously optimistic. I think there is a huge potential for AI to reshape work and employment positively, eliminating our menial tasks of everyday life. But if we don't deal with that properly, we're going to have a lot more complicated problems. Thank you very much. Good morning.
All right. Thanks, Professor Silvio, and let's put hands together again for this. I think I'm very inspired by the lecture. So before we start our next panel session, so we'll have about 15 minutes for coffee break where you can get your coffee outside. So we will be back at around 11:25, and please be back here sharp at 11:25. Thank you.